Well, for people who are joining us on the live stream, welcome to our 2018 Wolfram Summer School live coding competition. And here all of about 70 people. That includes the students from our summer school and instructors from the summer school and a few other random folks who are here to participate in our live coding competition. All right, and we should be ready to roll here. Problem number one, I'm going to display it, I'm going to set the banner, and I'm going to read it off. Okay, ready to go. Okay, the problem is odds before evens. Reorder the provided list so that all the odd numbers are placed for the even numbers, but the relative order of each set remains unknown. Now, I should say for people on the live stream that there is a second live stream which is coming from the Wolfram live streaming account, and Jesse Friedman is going to be talking through how Wolfram language is used to solve these kinds of problems. I'm supposed to be giving the more advanced version, talking about coding styles and so on. But I can't do anything until people have started producing. Oh my gosh, we've got Foxgoat has provided a solution, as has Lumen. And Foxgoat seems to have a second one, Total Annihilation, coming in with a solution here. Interesting. Wow, these are coming fast and furious here. Carl, Seb99, Mengyi, Terminator, Mac greater than Windows, all kinds of interesting handles here. Cheminator, MaxitG, another Seb99. We've got a bunch of repeat customers here. Ndada. There's definite similarity between quite a few of these solutions. Like some of them are identical. All right, judges, I think we've got to have got 3 correct solutions by now. How are we doing?
We have 3. We are finalizing the decision. Who's the victory?
So the primary criterion for the winner is who submits correct answer first. And who's... Yeah, these are all quite interesting.
Okay. So first place is Foxgoat.
Okay, so wait a minute. I should read off what. Oh my gosh, the problem is that my screen here is still getting all kinds of information that makes it a little bit hard to track down what's what. And it would be really useful if you put the solutions, the winning solutions, in the cells along with who the winners are. So the first place gets 3 points, second place gets 2 points, third place gets 1 point, and other people don't get any points for this problem, right? Okay. All right. So place in first place is the Foxgoat, and let us find the Foxgoat solution. Help me. Can you? Okay. So the ordering is Foxgoat is in first place, Carl is in second place, and Mengyi is in third place. And those solutions, we're still getting solutions coming in here. Can you send me the 3 winning solutions in a block? Or actually,
I did, and then it got swallowed up by the incoming. I'll resend.
okay. Okay, I just want to show people what was. Let's see how the solutions that were contributed here compared to the solution that was provided here. Oh, interesting. Okay, that's a very short solution there. Actually, that's shorter than most of the ones I've seen coming in. So let's take a look at what our winning solutions were. Did you send these to me? Wait a minute. Did you send me the?
There should be 3. It should be the
No, I'm not.
director, and then it should say winners. And it should have
There's nothing underneath the word winners in that cell.
You're not getting them right there.
I think you have to send them in separate cells. Okay, let's just check that the proposed solution here actually works. And yes, it said that all odd numbers are placed before even numbers. Okay, all right. Wait a minute. There's one that's coming through from Foxgoat that is listed, that's described by the Foxgoat as most obscure. Why on earth are those things in blue? What is going on here? Help! Oh no, there we go. So something, okay. So this is a solution, although that is pretty obscure. So just to explain what that's doing, the function through takes functions fg like that. And no, that's not even right. It does this, and it will turn that into f of x, g of x. So this is way too obscure. Why are we looking at this? This one is okay, now wait a minute. Where am I getting?
So in the big doc cell, hopefully it has the solution.
Oh, the big docked cell. No, but I can't scroll the docked cell. I can't scroll the docked cell.
All right, I can take it out. No, I can't send it in chat. I don't know why.
Okay, well, so our first solution from Foxgoat, and why is this in blue again? The first solution there was, I guess this should have just been list here. That was the
that's not the Foxgoat submitted 2. That the second one was the correct.
Oh, well, that one isn't correct.
That is not correct.
Okay, so where is the correct one? Okay, guys, we got to just to say for people the benefit of the live stream, the folks here, this idea of live coding as a sport is, we are at the very beginning of the process of making live coding a sport, and there's still a little bit of shakedown and debugging that's required to make that happen. We're getting closer. It's surprisingly complicated, all of the issues that come up here. All right, so did you send through these winners yet?
I can't send them in the chat, and all I can do is we can no longer find them because they're lost in the stream.
Well, you should have copied them out.
Yeah, they got.
Right. Okay. Well. All right.
The first part solution, same as the one you had there, very similar to switch on.
Oh, okay. Well, let's take a look here. Okay. All right. Okay. Okay. There we go. All right. So here, this was our correct solution from Foxgoat, and actually, it's a very direct solution. It's just saying first take. So it's a very, very clean and direct solution. It just says select all the things from the list that were odd, select all the things that were from the list that were even, and join the two lists together. So that's a very straightforward way to do it. Now let's see. Can we get the place number 2. And by the way, it's great to see a large number of correct solutions coming through here. All right, let's get number 2. Can we get number 2, please? There we go. Okay, second correct solution was by Carl. It's an interesting, slightly different solution. This is taking, oh, that's kind of cool. Okay, so this could be even simpler, I guess. We could just remove the odd queue, is that true? Aha. And now this is using the fact that sort by allows a list of functions, and it sorts first by the first function and then by the second function, I guess. And that, okay. Right, because without the list, this is just going to say use even queue as the only sorting criterion. This is saying use even queue and has a default sorting criterion that is different. I mean, I think we'd have to, let's see, do we have the third one here now? Okay, so the third correct solution is due to Meng Yi. Oh, it's the same as number 1. Okay, cool. All right, well, we've got, but actually nobody seems to have used the gather by solution here. So a lot of solutions involving cases. Let me show you a couple of others that are kind of interesting. Here's one by someone under the screen name of screen name. This is using pattern matching here. Oh, actually, it's the same. It's just a nice left-hand side that checks that the original list is actually a list of integers, and then it's the exact same solution as we've seen multiple times here. Okay, very cool. So there was a considerable convergence here in the solutions. Nobody got the solution that was suggested by the original creators of the problem, but many people got solutions that were equivalent to joining the selects. So we should be, by the way, we should be collecting this data because this is super interesting data about different kinds of equivalent programs and so on. All right, are we ready for problem number 2? Yeah? All right, let's go to problem number 2. Okay, here goes. All right, coming up now. Okay, this problem is the USA cellular automaton. Use the pixels of the provided binary image of the US as the initial condition for the game of life cellular automaton and return its 50th step as an image. Treat black pixels as filled cells and white pixels as empty cells, and vice versa. So I'm going to organize myself here. But that was all problem 1. No, this was all problem 1 up here. And I'm going to close up problem 1 here and prepare myself with problem 2. Oops. Actually, maybe the thing I should be doing is getting ready all of these. Okay, so we're waiting for solutions to come through here. For people on the live stream, I'm going to make a few other comments about, actually, you know what I'm really going to do is do some fancy footwork on my setup here to be able to better handle things. Let me see what I can do here. I'm going to stop sharing just for a moment here as I, no, actually, maybe I don't need to. I'm just going to stop sharing for a moment here. I should still be on audio.
Nobody yet has achieved a solution.
Okay, so no solutions yet for this problem, although there's something that just came through.
Oh, there's 5 possible solutions, no correct ones.
Yeah, he's stuck for a moment.
Actually, if somebody knows how to rotate the side monitor's display mechanism, that would be on a Mac.
Does anybody know how to rotate display for a secondary Mac?
Here, I'll show you what I'll share.
It has like a USB thing, and you just need to change the display setting.
No, I'm trying to get my secondary monitor to display vertically rather than horizontally. Anybody know how to do it? No. Ricardo, you can see what's happening and you'll understand why it's not working.
You want to do that? Yeah. Sorry, I'm a PC guy.
Okay, I'd be impressed if you know how to do this. So you're just displaying that way around, but I need to rotate it so that. Do you know how to do it? No, it's not a touchscreen.
So, okay. This is disorienting.
Well done.
Nothing correct yet.
Thanks. Okay, this helps my ergonomics considerably. Okay, so we're getting a bunch of solutions here. I might as well display for people on the live stream. I can at least display what's coming in. Stuff like that is coming in. Looks interesting, looks lifelike, so to speak, but is not correct. So we're still waiting here. I see all kinds of solutions.
Right. Place is in.
Okay, we've got one. Are you going to send me chat information about
The correct.
yeah, as they come in?
Yeah, I'm collating them. But if I post and people are still posting, my thing will get lost in it. So I'm sort of because it just goes up on the screen.
We should have a second chat session.
Yeah, and we can't.
You can also set it. Oh, you can do it.
Well, for people watching this live stream, we're learning all kinds of things about how to do live coding competitions. I suspect that for the remote folk watching on the live stream, we should have solutions coming in real time there. We just have to not display those for folks in the room, so to speak. I'm watching all kinds of different images. This is an interesting problem because it's kind of obvious whether you've got the right answer by what, well, it's obvious in many cases that you haven't got the right answer based on the pictures that are coming in. What? I have no idea. I don't know. I've not. What happened? Why did you not?
Don't receive the actual question arbitrary, we receive it here. So I don't have that actual information, which I made.
Wait a second. So for people on the live stream, okay, hold on.
We have one correct and two almost correct.
So I think one of the issues, apparently, some people are not receiving the images for the question in their chat streams.
The chat or on the doc. So you're not getting any images. Okay.
Which means probably that if you made one, then it probably isn't pixel for pixel correct. But so why would you not be receiving an image?
So should we take the two almost correct as being accepted? All right, I think we should do that. So can you? All right.
Okay, so can you send me the summary?
So everyone stop submissions so that we can get them. Right.
So the first correct solution.
Okay, all right. So let's So did you send? Have you sent over the solutions?
The first one is up on chat. On the doctor should be the most recent chat.
Wait a minute. Who is sending?
So
Okay.
the doctor.
Okay. All right. Okay, well, we have the first correct solution here. First place is Maxit G, and let's go run let's run over here the image, and now let's run their code. So here's the code, and there's that's the game of life rules. Actually, you can just type quotes game of life these days, but let's try and run this. Okay, so there's the US evolved 50 steps through game of life, and now we should have some other solutions. Do we have? Did you send through other solutions? So can we debug this? We need to know whether there are other problems that involve images in this statements of the problem.
Yeah, I've sent a note to Brady when he said there's nothing that they could do right now. It seems like it's just specific students who are getting. I don't know.
Well, maybe we should have a secondary chat channel. We can at least send it on a secondary chat channel.
Yeah.
So somebody can set up another chat channel and just send the.
If you're having trouble getting images in the chat, in this chat, go to Summer 18. So another file, new chat in Wolfram, and then do Summer 18, and I will post them there if you're having troubles getting images.
Okay, so folks, can you Okay, so the second place, the second is the Terminator, and the Terminator has posted this solution here. So, yeah, by the way, wow. Okay, so cellular automaton, people are not knowing that you don't have to say loss. So cellular automaton generates a whole list of successive states of the cellular automaton, but you actually don't need all of that. You can just, you don't have to say last of that. The third argument of cellular automaton can specify which results to get. And if you put that 50 in braces, you'll just get the 50th step. Okay, so this is color negating. Let's give this a try. Okay, that works as well. Okay, so second place is the Terminator. And third place, I don't seem to have here. Do we have a third place?
But it's not running. You know, but it's not running. So.
Okay, let's see what the solution that the original set as the problem. Okay, so the version, this was the version suggested by the original problem creator, and it's using, so it's color negating to get, that's interesting. So it color negates to make the cells on the boundary of the US be white cells, which correspond to value 1. And then it's running the cellular automaton, game of life cellular automaton for 50 steps. It's getting the image of that, and then it's color negating again. And the third place solution was total annihilation. And here is that solution. So again, oh, interesting. Okay, so this solution is almost identical, but it has a frame around it, which is within its rights. Great. So, okay, that was problem number 2. So this is a, so we got, somebody been measuring, there are timestamps here, so we know when those solutions came in. So how long did this problem take? Somebody know? We can, so first place,
When I posted the question, that's when it started.
yeah, so that was Maxit G was the winner here, and they were way back here. Here we go. Okay, 2019. So that and that was and the okay. So that was a 4-minute. That took 4 minutes to answer this problem. The first solution came in 4 minutes. All right. Are we ready for problem number 3? Let's see. So let's close up problem number 2. And here goes. Problem number 3. Okay. Everybody ready? All right. Here goes. Problem number 3. Okay. Problem number 3 is oil density. Calculate the top 10 country oil reserves per unit of land area. Return a list of country entities. I see. So this is asking for countries which where their known oil reserves are highest per unit of land area. In other words, roughly, what's the amount of available oil per unit of land area. Okay, so question is what to do with missing when there's missing data. I think
Missing is treated as not existent.
Right, so missing is ignore all countries that have missing data. I encourage people who are doing these solutions to consider the plausibility of their answers. If you get answers and your top country is, for example, Albania, it's probably not correct, since Albania is not known as a major oil exporter. So lots of solutions coming in here with lots of different...
We have 3 correct solutions.
Yeah, I should explain for people on the live stream that we have about 70 people here who are students and faculty from our 2018 Wolfram Summer School, and they're people from many different backgrounds and some different levels of the kinds of, these will be a whole range of Wolfram language questions and problems that we'll be asking here that go through things that are traditional kinds of programming to things that involve data, images, etc. But it looks like we have, for problem number 3, we do have 3 solutions now.
Yes.
And am I about to get? Okay.
I'm just reading copy of chat. I'll post the first answer.
Okay, so here we go. We're about to actually get
All right, so submissions are closed, so please don't send any more.
and
Sorry, I posted the answer. I need to post the question.
okay, it looks like the fox goat was the first to post a correct solution, but we don't know yet what the fox goat solution was.
Yes, I have it.
We can point to our clever use of hash to auto-check some of the answers.
Yeah, this would be. I'll show people on the live stream. This was that's the list with the hash wrapped around it, because this is the way that the answers were checked, is by whether they have hashes that agree. So on this problem of oil reserves per unit of land area, Kuwait is the winner, followed by Qatar. It's interesting list. I had no idea that Trinidad and Tobago was so high on the list. Okay, so the solution, the fox goat solution, was, wait a minute, you didn't send through the solution.
I have now.
No. Oh.
Takes a while.
No, I don't see it.
They just see Fox Scope.
Yeah.
I am not seeing it. Oh, suspense. Come on, let's. I'm not seeing the solution. Can you post in a separate cell? We're making use of, for people who are watching on this live stream, it's a slightly complicated technical setup here that involves all sorts of chat sessions running that can exchange code and so on, using our new, fresh, hot off the presses Wolfram chat system. And this is a great test of that.
Yes, total annihilation. Yeah, and this was the second.
Okay, well, I don't see the first solution yet.
The director has just posted Fox Scope solution.
Okay, so this is the Fox Goat solution. Wow, okay. So let's try and decode what was happening here. So entity value is asking for, of all countries, this is asking to produce, so if we say this is going to give for all countries, it's going to give the oil reserves and the land area as an association. Okay, so it's downloading 500 values, and there it's going to give for country 0 barrels, and that's the land area. And then the rest of this is asking to divide these. It's somewhat exotically, it's using a curried form of apply to do the divisions. Then it's reverse sorting the result, and then it's pulling out the keys to actually get the list of countries. Okay, so that's the Fox Goat solution. Then we have the next solution was due to total annihilation, and I'm not yet seeing that solution.
Okay, that should come through.
Okay. Okay, and this is total annihilation solution coming up next. Let's see. Interesting. All right, so this is asking, I don't know what that is doing there, but this is asking for the entity class of countries. Okay, so this is saying, give entity value of the oil reserves of a country, the area of the country, and the entity. It's interesting that area and land area, one used land area, the other used area, and the results are, let's see, the results I'm assuming are the same. And for extra fun, we could say geolist plot of this and find out where those countries are. There they are. Okay, and the third solution here was due to maxit_g. It's a slightly longer solution. Let's see if I can get that. Oh dear, 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 no, I cannot. It's a 3-cell solution which computes the countries, the oil, and the area separately, and then combines them together. And for technical reasons, it's a little hard for me to show that particular. Okay, but anyway, so this was this problem was solved in approximately how long? How long did it take for us to get a solution to this problem? About 5 minutes, I think. It's kind of impressive that it's possible to do that. But this is let's take a look at what the original problem setter had proposed as the solution. Okay, so this is again using entity value, constructing for each country the pair of oil reserves and land area. and then deleting missing elements and finding the largest from that color. All right, let's go on to problem number 4. Okay. Are we ready? Okay, here goes. Okay, so the problem is US tour. Calculate the shortest tour that visits all state capitals in the continental US once and returns to the start. Return the length of a driving route following this tour as a miles quantity rounded to the nearest whole mile. Now, this is a complicated one. All right, I'm going to talk a little bit for benefit of people who are watching this on the live stream. I'm actually going to, I wonder what the range of this wireless microphone is. So, for from the so just to so we have a collection of students. We have a lot of people apply. We have great students this year. I think we have 64 students. That's about our typical number. And students range from undergraduates, graduate students, some more experienced folk, and a smattering of high school students. I'm not sure how many we have, maybe 1 or 2 or 3 this year. We have 3 tracks: a science track, that a technology track, and an education track. The science track particularly is oriented towards things, basic science kinds of questions, and particularly things that came out of my book, A New Kind of Science, together with basic science issues that come up as we develop our technology at Wolfram Research. Technology track is really about implementing technological solutions, and the education track is really about creating educational material that makes use of the Wolfram technology stack. So it's a 3-week summer school. We have it at Bentley College in Massachusetts. And we've been doing it now for 16 years. This is, I think, our 17th summer school. And the typical, the main focus of the summer school is for everybody to do an original project. And we just finished, this is the end of our first week of the summer school, and we just finished coming up with projects. We hope they're great projects for all the students. I view it as my moment of extreme professoring in the course of the year, because I get involved in figuring out the right project for each student. And that's a bit of an intense process. We also have a whole collection of lectures and workshops and brainstorming sessions that we sort of do collectively. There's also a kind of a homework exercise, which is due in the next day or so, which is to write a computational essay in the form of a Wolfram notebook using Wolfram language code. And a computational essay is something that uses computation and words to explain an idea. And we've asked people to write an essay that is about a topic that they already know about, which they are explaining computationally. So let's see. So I think now we can come back here to the live coding competition. This we're working on problem number 4, and do we have?
Just have one correct. We're still waiting for.
Okay. What's the correct one?
Foxgo.
Okay, the fox goat again delivers a first correct solution. And we are waiting for 2 more. I'm impressed that I'm seeing a lot of at least partial solutions from lots of different folk here, which is very encouraging. I should explain something about kind of the sport of live coding. Yeah, really, the kinds of problems that we're asking here are, we're still trying to debug the right way to deliver live coding as a spectator sport. I kind of think it would be more fun probably on this channel for remote folk to be able to see solutions as they're submitted, and maybe also we should have a video of things that are going on here. But the possibility of live coding as a sport is really enabled by our language, because it's kind of the unique situation in which it's possible to have small amounts of code that are fairly fast to write, that do interesting, a diversity of interesting things, and where we can have.
Jaguar, you're on the ground.
So we're still waiting here. We're seeing a lot of solutions coming in. I'm seeing here, let's see, how many solutions have we had so far? So we have 1 correct solution from the fox goat after apparently an incorrect initial solution. We've had variety, let's see, 1, 2, 3, 4, 5, 6. Okay, we've had 10 people so far contributing potential solutions here. It's very interesting. Okay. I encourage people who are to note that the problem statement asks, in the end, the length of a driving route. So it's not sufficient to just know the distance between the state capitals. You have to know how far it would be if you were to drive by car.
Just one, you need to post and evaluate the solution, not just your input code. Quite a few people that are on the right track, they haven't posted their answer.
Right, so comment for people in the room. When you post through the chat system your answer, make sure that you evaluate it and post both your code and its output. All right, well, there are all kinds of beautiful looking solutions coming through here which don't look quite correct. Okay, the real question is what's the actual, how far do you have to drive to actually visit all the state capitals in the US? All right, well, maybe I should, for folks on the live stream, maybe we can go back and look a little bit at some of the earlier problems here. So our first problem was to reorder a list so that odd numbers come before even numbers. So this is a very straightforward problem. We can just take that list and we just need to get the odd numbers in the list. There are the odd numbers in the list, and we also get the even numbers in the list. And the way we can solve this is just by saying join the list with odd numbers selected to the list with even numbers selected, and that will give us the result for that. That was an image processing problem, kind of. I don't know whether you call it image processing. It was doing something to an image. The problem was to take this thickened border of the US, treat it as the initial condition for the game of life cellular automaton, and evolve it for 50 steps and show the results. There are all kinds of little. Actually, I'm going to do, just for fun, I'm going to, again, myself, and let's take this over here for problem number 2. I'm curious what it looks like if we take that image. Oops, that's not what I want. I want the image over here. I take that image, and instead of computing just the result, let's try doing this. Let's try computing all 50 steps, and then let's try making a 3D image out of that. So what we're going to do here is, I hope, okay, I don't think we want the image negate there. Let's try getting rid of the image, color negate rather. Okay, there we go. So this is now the space-time picture of the US as a game of life thing. So we can see like Florida turns into a little periodic structure there.
Check your units. If they're in miles squared, calculate something different.
So we can evolve. Oh, there we go. That's rather elegant. That's the US evolved with the game of life for more steps. And we see all kinds of structures that are developing here. Let's curious what happens if we just run it for a lot longer. Let's try taking the US and evolving it for 500 steps. So this will make a very tall object. So it's still all sorts of things are continuing to interact here, and we see we can look at it from the top, or we can see the thing. That's kind of nice, a nice image to represent kind of a live coding challenge.
someone has a right answer, except it's not round.
Is it possible to send the code only? It takes forever to send the what? The code only.
No, because if it can't run within the time, if it takes too long for you to run it, it'll take too long for us to run it.
There's a 1 minute evaluation limit.
So we have one correct solution, one solution that's correct, except it is rounded. That's what we've got so far.
Okay, so it's one of these. I'm being, for people on the live stream, apparently we have one correct solution and one solution that is almost correct, but there's a read the problem. And in particular, there's the problem had asked for the solution to be rounded to the nearest mile, and it's one of these cases where there's some, you have to round out the solution. Okay, so now I'm curious. I'm going to keep. Problem number 3 was to compute which countries were the top countries by ratio of oil reserves to land area. So actually, that was the top 10. Now curious what the top 20 look like. Okay, so my gosh, Denmark? Is there oil in Denmark? I had no idea. And Trinidad and Tobago really surprises me too. Most of these other ones, I've heard of drilling operations in those places. I wonder, maybe Denmark has oil, or maybe that's from the North Sea. I wonder whether, I wonder what other things appear going down to 30. Let's try that. Okay. Actually, now let's look at where in the world those countries actually are. So let's do a geolist plot. Again, going down to the 30th country. Okay, that's interesting. It's quite a diversity of countries that have decent amounts of oil reserves per land area. Now I'm curious what the corresponding result would be if I did oil reserves per capita of population.
We have 2.
Oops. There. So I see, by per capita, we've got Kuwait, UAE, Qatar, followed by Venezuela, Saudi Arabia, Libya, Canada. Okay, so, but what about, wow, Trinidad and Tobago must have a substantial population. Interesting. So here Kazakhstan is making an appearance, which Kazakhstan is much lower down here. All right, let's see. How are we doing on problem number 4? Let's a reminder, problem number 4, the current problem we're working on is calculate the shortest tour by car that visits all the state capitals. And how many correct solutions do we have so far? Okay, 2 correct solutions so far have come in for state capitals. All right, I'm going to keep playing around with the oil business, so to speak. Let's look at, I'm curious, with oil reserves compared to GDP. And there, which countries win in terms of ratio of oil reserves to GDP? It's interesting. So Libya is in place, high oil reserves, not so high GDP. And Venezuela, I don't know what the GDP of Venezuela has been doing of late. That's obviously a place with a troubled economic situation in recent times. So actually, I'm now curious, if I just look at GDP, if I look at the GDP of Venezuela for the time that we have it available, and I make, this will give us a time series of Venezuelan GDP. So let's do a date list plot of the time series of Venezuelan GDP. Wow, it goes way up. Wowee. Let's go look at. So I think that must have been due to oil, but I'm really surprised that the GDP. Actually, I wonder what happens at GDP at purchasing power parity, which would be in official converted currency. Let's take a look. Let's say Venezuela, and let's look at GDP. GDP deflator. What is that? No, what I want is GDP at purchasing power parity. Let's take a look at. But before I play around trying to understand more about Venezuela and it's GDP at purchase parity. It sounds like we have the correct answers for our problem 4. So can you send me the solution?
Limiting solutions, we have 3 winners. Should I send them?
Why don't we set up a separate chat between you guys and me? Let's just do it.
What would just be useful is to go to that, click on this and post it as a.
Yeah, I know. But let's set up a separate chat.
We can use summer 18. So file new chat, summer 18.
I thought you told people to use that for something else.
That was just debugging something with Chris.
Okay.
I think it did show.
Is it uppercase? The summer 18, is it uppercase?
It's lowercase.
All lowercase.
Okay. So let's see. So you just posted through.
I posted in both summer 18 and to the main.
Okay. All right. Okay. All right. So here is the Fox Goat solution to this problem. So this first piece here, what does this do? This finds, I guess it finds the positions. Oh yeah, poses actually should be read as poses, positions of all the state capitals. And now this instance generates the list of state capitals in the order of their shortest tour, and then will compute the travel distance. And the answer is 13,407 miles. And I wonder, I'm just sort of curious, if I take that and divide it by 60 miles per hour, the question is, how long will it take you to visit all of those places? Let's see. And the answer is 223 hours. That's actually not very long. Yeah, 9. So it says 9.3. Oh, that was divided by 24. That will give it the number of days. So that's 9.3 days. Okay, so that's our first solution here. Second place is F. is a large number of F's is the handle here. An unknown number of, let's see, can I copy the, no, I cannot. That's an interesting problem. I can't copy the, okay, so it's the F, the F person, and that is their solution. So this is now computing, well, let me not talk in detail about the solutions here right now, because, but this is, okay, that was nice, and it gives the same answer. Very cool. All right, and the third solution is W. Zhu, and that solution, let us pull up that solution. If I could only select it properly here. There we go. And here's that solution. So all of these are finding, wait a minute, no, that's not the same solution. Okay. That was really fast. Oh, that's because it had already hashed all of this data. Very cool. Okay. So that was our 3 solutions for problem number 4, the US tour. Let's take a look at what the original creator of the problem thought it was a good solution. Very similar, actually, to what we're seeing here. Yeah, it's that's I mean, this is using all kinds of fancy algorithmic stuff. For purposes of people here, let us go to number 5.
Not to throw a wrench in the mix, we were going to award a discretionary point to total annihilation for bringing up the valid point that Alaska is in fact continental, just not contiguous.
Okay,
so I think we all misinterpreted this.
This is the problem with writing things, and so I'm going to, for people on the live stream, I'll just repeat that comment. The problem with writing things like problem statements in English rather than in Wolfram language code is that they are not precisely precise. And so Total Annihilation wanted to register a complaint saying that Alaska is part of the continental US, just not the US. So, yeah, valid point. That's why the code says what the code can say it precisely, the English does not. All right, let's move on to problem number 5. Okay, ready to roll here. And problem number 5. Okay, gene music. Take positions 1877 through 1882 in the sequence of the human gene SCNN1A. Convert each base pair, A, C, G, or T, to its respective musical note in the middle C octave, treating T as the note E. Assemble the notes in succession, each playing for 0.3 seconds using the piano instrument, and return these as a sound object. Are we about to hear in this room lots of curious noises?
A bonus point if you get the answer right, and you can also recognize the tune.
Okay, yes, so comment for the live stream, bonus to anyone who recognizes the tune when they when they manage to solve this one. Okay, so for folks on the live stream, I'll just comment a little bit on the previous problem. This is a problem that requires a bunch of different Wolfram language capabilities to solve it. Let's go back to the original solution here. This is making use of the built-in knowledge base that which knows about what are the capital cities. Just look at this piece here. This will tell US. US states is going to be a class of entities, and those will be the capital of those states. And now entity value position will tell us, or we could also use geoposition, I think, but let's just say entity value position will give us the geopositions in lat long. We need to be able to then say, find the shortest tour. So that's using this. So far, we've been using kind of the knowledge-based capabilities of Wolfram language. Find shortest tour is now going to make use of algorithmic capabilities to be able to solve the traveling salesman problem with great speed here. There we go. Now notice that the result from this is a tour 1,600 miles. But the problem statement had asked for a travel distance. The travel distance is a distance. And so the driving distance turns out to be somewhat longer. So for example, we can just take, let's just take first of percent, well, first of percent 55, that will tell us the direct sort of aeroplane distances. And so this is saying that the driving distance is about 26% longer than the airplane distance between state capitals in the US. It's kind of interesting. So that sort of tells you something about the efficiency of the freeway system, in a sense. That it's you only lose. I think it's pretty impressive actually. You only lose 25% of distance as compared to sort of direct airplane distance. following the roads. And I guess what we can do here is, let's say, I think we can say, let's go ahead and do this. Let's say in here, we can, let's go down to the bottom here. Let's take this, and instead of saying travel distance, I think we can say travel directions. And let's see what happens here. This will give us, I think I have to look up documentation here, shocking, to know how to, I'm going to say, let's see whether we can actually draw the freeway-based travel. Okay, so here we go. This is going to give us the travel directions. Let's see whether we can do this. There. So this is now going to hopefully compute the travel. Oh, that's really cool. So there's the freeway-based route around all the state capitals, and we might compare that with just let's say we just say line there. This should give us just the pure aeroplane distances to all the state capitals. I wonder what I guess there are mountains here, which mean that you have to visit. I'm going to embarrass myself by not knowing. Oh, this is so embarrassing. Is that North Dakota? Yes, I think so. A bunch of solutions coming in for the music question. And do we have 3 correct solutions?
We do, but our computers are having trouble reproducing them.
I think it's something we're trying to
Yeah. Right, I'm going to post. So no more submissions. We have.
Oh, you don't need to worry about that because you're posting on a different channel now.
So do you want us to send this over 18?
Yeah, so you can go on posting whatever you want. Okay, so we should be getting some solutions here for problem number 5. And let's close up our okay, problem 5. Here we come. All right. In first place, the frequently seen creature fox goat. And the fox goat solution is, I'm going to try and construct, maybe in one of the breaks here, I'm going to try and construct a fox image. But okay, here we go. So this is now hopefully reading in. Oh, it's got to read in a bunch of genome here. So it's got to load onto my computer from the knowledge base, knowledge about the human genome, and this is going to get. So what this is doing is to take genome data from this particular gene, and it is okay. Let's see. I don't know if this transmits through the chain of things that goes across the live streaming system. But let's see whether I can play this. I can't hear anything, so I don't think we're successfully playing this, and I'm not going to try humming the tune here. Why isn't that working? Let's just try this. Nope, I am definitely not hearing anything here, and in fact, my computer has is muted. But anyway, those are the notes. And what this is doing is it's extracting the characters from that genome. It's extracting the ones at those positions and as sound notes. Okay, so second place was total annihilation, and total annihilation's solution to this is like this, very similar solution. A string cases, oh yeah, string cases, that's funky. Oh, string take, that's right. String take is taking elements 1877 through 1882. Now the real question is whether this is, anyway, third place is maxit G. And let's look at the solution there. Ag. Okay, so that's again a very similar solution actually, just using string take. It's really very similar to the previous solution. So, okay, that was our problem number 5. All right, are we ready for problem number 6? Hello, everybody, are we ready for problem number 6? Yes? Okay. Not quite sure how many we're going to keep going through here, but let's keep going for a little while here. I hope people, so actually I'm curious from people in the room, who here has submitted an answer for every problem? Okay, a couple of people. Okay, three, at least 3. Okay, who here has submitted a solution to at least one problem? Great. Okay, that's the majority of people here. That's great. Okay. Well, all right. Let's so let's keep going. We've got problem number 6. So let's open it up. This is called Pi Walk. Find the city closest to the end point of a geodesic path, starting at the coordinates of the city of Waltham, which is where we are, that for each digit with value n of the first 400 digits of pi following the decimal point moves forward 5n kilometers and rotates clockwise to a bearing n over 0.025 degrees from true north, return a city entity. Oh, this is so and it's suggesting using functions like geodisplacement, geoentities, geodestination, geonearest, geodistance. So this is kind of cool. So this is a geo problem where we're starting from pretty much where we are now, and we're using pi to walk around like a turtle, except that so each successive move is determined by the value of the digits of pi, and it both goes a distance that is proportional to that particular digit, and it rotates its bearing, rotates clockwise. Wait a minute. So I see. So the walk at every step, the walk goes. So if there's, for example, a digit 1, it will go 5 kilometers, and it will turn 1 over 0.025 degrees. Okay. Well, just for my benefit, 1 over 0.025. Oops, this is problem 6. Just for my benefit, I just want to understand what the 1 over point. Okay, so that's basically 40 degrees times n. Wow, it's quite wild. Okay. Interesting. Well, I'm curious. That will make a nice graphic, at least. Somebody on the live stream is asking whether Wolfram language supports TLS out of its standard API. TLS. What is TLS? I'm not knowing what that is in this context. Oh, transport layer security? Why would we be Why is that relevant, and what is that? I mean, we're supporting, I don't even know what that would even mean. I mean, we support HTTPS and things like that. Okay. Oh, it's a successor to SSL, it says. I'm fairly confused by that question. Oh, someone is asking on the live stream, how is Wolfram language implemented? It's about 50 million lines of code and about some number of terabytes of knowledge base. And yeah, of course we use HTTPS. And how is it implemented? Well, it's a big language that is mostly written in itself and has it's ultimately an interpreter, but many pieces of it are compiled, and in fact, soon even more of it will be compiled. But it's kind of it's a big language with a lot of different kinds of capabilities. All right. Well, I think we're waiting here for people to follow the Pi walk. I'm going to go offline just for a second here. Okay, back for people on the live stream. And
Nothing correct yet.
I thought I would talk a little bit for folks on the live stream about the process of this live coding competition. Ah. We are working on So we're working still on problem number 6. Apparently we have one correct solution to problem number 6 that's come in. I thought I might mention for folks on the live stream, we have a whole, we've been trying to develop a whole set of guidelines for live coding competitions. These have actually been developed by Jesse Friedman, who's still quite young, but started using Wolfram language when I think he was about 11 years old, and is an experienced user and creator of things in the language. He's been developing the guidelines for live coding, and so there's a long list of rules, criteria, guidelines. So scoring: solution is considered correct if it produces the expected response, follows all of the rules for solutions, and is not rejected by the contest referee as disregarding the spirit of the question. Okay, so for a solution to receive any points, it must be correct. Interesting. Okay. So the rules, you have to be assumed to be running a particular version, now 11.3.0 of Wolfram language. You're encouraged to use the official documentation in creating your solutions. You should assume that any questions involving linguistic analysis concern the English language, unless specified otherwise. When solving questions involving analyzing a list of words in a language, you should treat word list as the authoritative list of words. So when solving questions involving entities specified by natural language, you should treat the default Wolfram knowledge-based interpretation of the entity name given in the question as its authoritative representation. So if there's a spring field, you should assume that the spring field that is by default picked up by the natural language understanding system is the appropriate spring field, although I wonder how that would work if there were multiple geographic locations where this live coding competition was going on. So let's see. You should generally deal with questions involving querying a property or properties across all members of an entity class by using entity value, otherwise specified. Not quite sure what that's about. I mean, I understand the criterion. I don't know why it's there. Okay, so there are all kinds of things about missing values. Yeah, so you should, your solution should evaluate and return their full output within 1 minute of wall clock of the moment of evaluation, unless otherwise specified. I assume that's as evaluated on the judges' machines. We have 3 judges who are analyzing these solutions as they come in. So those are some of the rules that Jesse Friedman has come up with for our competition here. I thought it might be interesting to people to talk a little bit about the summer school that we're at. For people, let me just bring up the summer school homepage here. Let's see. We are going to go to, oh, look at that. We've got the summer school. This is our summer school homepage. We've been doing this, as I said, for well, since 2003. And so last year, for example, let me show you, for example, last year's, let me show you some of the projects from last year. This was last year's summer school, and here are some of the projects people did. Analyzing quantum systems with and without machine learning. nonlinear feedback shift registers, doing function approximations using neural nets, predicting the location of exons using machine learning. Sort of interesting. There's a small neural network that was predicting where there are exons in genomics. So these are a bunch of the projects that were done last year at our summer school. Okay, 3D modeling of topographic maps. I don't remember that one actually. This one actually has turned into that project, that summer school project, has turned into the function find equational proof in version 11.3. Okay, I'm told, returning to live coding, in problem 6, there are so far 2 correct answers that have come in, and we're waiting for a third correct answer, and then I'll talk about problem 6. So coming back to the summer school, this quantum computing framework has also turned into a piece of production code. We've been working on a quantum computing framework based that started with this project at the summer school. Will be a lot of different things that were done in the summer school have been used in a variety of ways. Each one of these summer school projects, there was a community post that describes the project in more detail. So people are curious. I actually, we of course, because we spent the week assigning projects for this year's summer school, we can talk a little bit about what some of those projects are. I had a list actually that of projects that I had suggested that people might be interested in, that list, let's see, I seem to have, wait a minute.
Do you want me to send that list to you?
No, I'm looking for the list of actual projects. Okay. So we're still waiting for the third correct solution for problem 6. Let's see what we've got here. Interesting. I think there was a hint given that the correct answer, are you giving a hint for the correct answer?
6 letters long.
Okay, the hint for problem 6 is that the answer is 6 letters long. Interesting. Okay. People are working on this problem of starting from the city of Wolfram, which is where we are right now, following, using the digits of pi to determine a walk that will be taken. Okay, meanwhile, let me just describe a few of the projects people are working on here. I think this is a quite incomplete list that I have before me right now, but I think this list that I have is not the complete list. Okay, well, some examples of projects are being worked on at the summer school this year. Make a machine learning system to determine the size of a 2D aerial image. So if you're shown a chunk of geo-image of the Earth, what is the scale of that geo-image? Another one is to look at tiling of polyominoes to create an efficient algorithm for determining how to tile a polyomino. Another one is use a neural net to identify different chart types. So you're showing a picture and it's like, is it a bar chart, is it a pie chart, etc. And then also to extract for things like pie charts and bar charts the actual values from the chart from an image. Another one is working on reinforcement learning on video games and such like. Another one, let's see. Another one is kind of which will be being shared in social media, is develop a method to measure how long it takes people to add fractions. And that's as a way to understand which kinds of fractions are the most difficult for people to work with as a piece of education research. The claim is that I think 3 and 7 are the scariest numbers in the range 1 to 10. Then let's see. Yeah, we've got all kinds of interesting projects coming here. Let's see, we've got another one for detecting meteorites in the atmosphere using software radio and then analyzing their behavior. Another one figuring out how to take a piece of text that doesn't have commas and other punctuation and use machine learning to figure out where the commas and punctuation should be. Another one is about resolution theorem proving. Another one, gosh, all sorts of things here. Another one is about taking shapes, for example, of animals. For example, taking 2 animals of the same species that are not quite the same shape because they have different allometry, different growth rates for different, well, like humans. Some of them are taller than others, some of them are wider than others, some of them have longer arms than others, and so on. Figure out a minimal transformation to get from one shape of creature to another. So those are a few projects. Here's another one, using machine learning to identify incorrect programming syntax. So when there's a syntax error in Wolfram language, what is the most likely correct syntax that should have been typed? Where was that? Where should the missing bracket be added? Where should the comma be added, and so on? Another one is taking chemical data from Wolfram language and rendering it as a geometry in a game engine, so that one can essentially do a quantum scale video game. All kinds of interesting, all kinds of interesting projects here. These are. Let's see. Open up a few more here. Oh yeah, here's another one, determining the essentially borders of mountains from satellite images. So if you've got a mountain and there's a question of where, sort of one way to define it is kind of where does the water flow down from that mountain peak, and how is there a sort of a watershed between mountain peaks based on geoelevation data. Another one is creating a website that generates 3D printed objects. So you basically give a mathematical function to a website, and out comes a connection to a 3D printing service that you can get your 3D object from. Another one is taking using sources like Wikipedia to generate a kind of social network of mathematicians based on who gets mentioned in whose article and so on. So we've got, well, lots of different things here. All right, how are we doing on problem number 6, the pi walk? I think there was another hint given.
Said it is in Canada.
So it is 6 letters long, and it is in, and the city that you reach is in Canada.
Two correct
for cities of that 6.
like random choice city lane.
Well, not when you're cheating.
All right, how much?
We could just say we take the 2 solutions and move on.
I think we should do that. I think unless somebody thinks they're really, really close. Somebody think they're really close? Should we wait for a third?
Our submission rate has been decreasing.
Okay, fine. All right, fine. Let's so somebody says there is a 6-letter place in Canada which is Quebec, but I don't think that's I don't think that's the answer. Okay, so let's see. So we did we
I posted them to
Okay.
or
okay, so first place so the answer turns out to be Altona, and I don't know what and let's take a look at the solution here. So let's see, we've got this walk here, and this is okay, so the answer is Altona. I have no idea where Altona is, so let's just do a geolist plot just for my curiosity. Let's say geo range is Canada. Let's find out where it is. Hey, wake up, computer. What's going on here? Is that failing in some way? Oh, there we go. Oh, it's really close to the Canadian border. Wow. Okay, so anyway, that's our first solution from Terminator. Our second solution is from Landston. And from Landston, we have this solution. Slightly longer, but apparently gets the job done. So let's just take a quick look at how these things work. So this seems to be, okay, so this is a, wow, okay. So this is taking geoposition here, and what it's doing is it's taking the real digits of pi. Okay, so let's see what those digits are. Those are the first 400 digits of pi to the right of the decimal point, and it's folding those into a geodisplacement. So the geodisplacement takes each successive digit and takes the geodisplacement is specified as a distance and an angle. And so those successive geodisplacements will get, so if we just take this, then we should get a list of, if we just say line of that, we should be able to get, and then we say geographics. This should show us the successive, oh, what the heck happened there? What did I do wrong? Okay, let's take a look. Oh, yeah, right. Okay, wow. Okay, so those are the digits of pi being used to get from where we are now, narrowly avoiding the lake and winding up somewhere near the Canadian border. So, okay, so that was one solution, this just used fold to get to the destination point without making a list of everything. And this was our second solution from Lanston Chu. Digits of getting the digits of pi by multiplying by a power of 10 to move the digits onto the left-hand side of the decimal point, and then computing from that. All right, let's take a look at what the original problem setter's solution was. Okay, interesting. So this is using pretty close to the solution that was oh, that's interesting. So that instead of using fold of geodisplacement, this just used the geodisplacement. Oh, I see. This is the last of the geodestination. So this is using the fact that geodestination can take a list of displacements, which in the other case was explicitly using the fold. All right. Well, I don't know. Are we going to survive another problem? Yeah. Yeah. Okay. All right. Let's go on then.
And that was a contentious problem, so we may need to revisit if there's a tiebreaker that needs to happen.
Okay.
But yeah. So we acknowledge that there were some contentions.
So that problem. So there were issues with the description of that problem. Is that correct?
Yes.
Wow. It's so hard to write stuff in English. People should just write it in Wolfram language, for example. Then everybody would understand. And this is why computational contracts written in our language make sense. Because if you write a contract in English, who knows what it says? If you write it in code, then there is a precise meaning to it. So given this piece of code, we actually know what we're being asked. Okay, let's move to problem number 7. Okay, here goes. Problem 7. Okay, this is noun reversal. Reverse the characters in place of all single word nouns in this text, and by cases, return a string. So the text is the text of the Gettysburg Address. We're being told to reverse the nouns in the Gettysburg Address. You know, I thought there were these weird things where people would take audio presentations of political addresses and do things like reverse the audio in those political addresses and find all kinds of strange conspiracies that seem to exist based on the reversed text. Okay, let's see. All right, so just for people on the live stream, let's talk a little bit about the solution to this most recent problem here. I think we should be kind of trying to collect some graphics from all these problems because these are pretty cool. There's some pretty cool graphics here. So maybe I should try and make this graphic look nicer. Let's make the style of that line be, let's say, thick and let's make it blue. Just so we have a nice. Actually, I don't really like the blue there. Let's make it purple. I'm just trying to assemble interesting images so that we can collect these together as indications of what these problems were. So actually, let's see. That's a good image for that one. This one. What's a good image for this one? Well, maybe it's just the sequence of notes. Maybe there's a more interesting version of that. Let's take a look. Did we have an interesting picture for this? Yeah, I think we did. I think that was a pretty interesting picture. Actually, you know what? I'm going to start assembling at the bottom a summaries, and I'm going to take something from here. I'm going to take this piece of code here, and I'm going to use that as a summary for that problem 6. And then I'm going to take, so I'm just assembling these things. I'm going to go. And I'm going to
We have 3 correct answers.
oh wow.
We have actually more, but what a correct answer.
Okay, I'm not even going to have time to assemble my summary here of other problems. We apparently have 3 correct answers already for problem number 7. So if you can send them through, I will announce them. I was going to start talking about, okay, all right. These are long answers. Okay, so in first place, let's see, you have listed maxit G, but you don't list anything for that. Is maxit G the first place solution? Okay, so let's look in second place is total annihilation, and that is problem 7. So let me make a thing here that says problem 7, and this is the total annihilation solution. Gets the text of the Gettysburg Address, finds the nouns in it, and replaces the nouns by the string reverse. 4 eroks and 7 srai ago, our Shreftaf brought forth upon this Tenek Tinok a new Noyatan. Okay. And let's see. I seem to have 2. Okay, in third place, we have a very short solution from, oh, I see it. It has the text solution from Lumen. Very similar, actually, to the previous one. And let's see, do we have the Maxit G solution?
Should be in the summary.
I don't think so. Try sending it again. Okay, but in any case, this is, okay, here we go. So this is now the Maxit G solution, which was the first one to come in. Actually, we should assess whether the first to arrive solutions are also often the shortest solutions, or whether short solutions arrive later. This is a short one. There is, yeah, it's a nice, very, very short one. Using association, but using the fact that text cases is returning an association, and then, wow, this is pretty cool. This is, well, this is using the fact that it returns an association, then this is turning the key arrow value in the association into a rule which is being used by string replace. This could have some odd bugs if it thinks that if there's a word, yeah, this one isn't really quite right. Because if there's a word, it might happen to be right for the Gettysburg Address, but if there's a word that appears as a noun somewhere, like the word set, for example, which can be a noun, but may not be a noun, this is saying just find all instances of all nouns, and for each noun, wherever it may be, replace it with the string reverse of that noun. So the word set, if the word set appears in a verb as a verb, let us set our path or something, then it will get replaced even when it's in that verb position, if it ever occurred as in the noun position. So I would say that solution is a bit unconvincing. But nevertheless, probably for the Gettysburg Address, there isn't in fact an error. So, but it's probably, and I'm sure from the hash of the solution. All right, let's take a look at what the original proposer solution was. Okay, this uses a string replace part because it knows the positions of the nouns in the original text, so that can't make a mistake along those lines. All right, well, that was a nice quick one. So let's now go to problem 8. Now I closed up everything. Okay, problem 8. Okay, and the problem is coming now. Okay, text edit distances. Sort the given list of languages in ascending order by the edit distance of the language's translation of the United Nations Universal Declaration of Human Rights from the same text in English. Use example data to obtain the texts. Return a list of the language names as strings. So these languages, including Esperanto, I see, take the UN Declaration of Human Rights and find out which languages are, according to edit distance, the furthest from English. I'm a little confused here because many of these languages don't have characters that are, every character will be different because Chinese, for example, doesn't have, has a completely different ideographic writing system. All right, let's return here to our...
And the languages are in the chat if they didn't show up in your doc cell. So I just sent it, you should have it in your chat.
Okay, so... So I'm just, let's see, I was talking a little bit about projects at the summer school, and I all kinds of cool projects this year. Another one, determining the amount of solar energy that can be generated by solar panels by figuring out for a particular city, let's say in Mexico, by looking at the total area of roofs of buildings that could be covered with solar panels and comparing that with things like populations of cities. Another project is developing a symbolic discourse language for card games. That is, given it's kind of like what we're doing in this live coding competition, there's an English language description that you might give of a card game, but you can also imagine having a precise Wolfram language description of not just the scoring for the card game, but also the set of rules for the card game. So, and then a representation for the successive moves in the card game. And then you can take games and, for example, determine whether they're valid games, start games, start doing various kinds of assessments of games. Anyway, let's return to our problem 7 here, and let's see whether we can get some nice graphics out of this. So we are, let's for example, let's take the Gettysburg Address and let's make those, I am curious to take the nouns here and make them not just string replaced with, let's see what happens if we try to put, I wonder what would happen if we said string replace the cat on the map. Let's say cat, what does it do if we say cat arrow style tack red? Does it work? Oh yes. Oh, it's a bit, because it has it explicitly shows the okay, but what we can do here, I wonder how we deal with that, because that's not really a string. That's an expression there, so it knows, string replace knows to make that an expression. I wonder what we would do to make this. I would guess what we should do in here, instead of saying string replace, well, okay, let's do this. String replace of, let's say, framed of that, comma, background, arrow, yellow. Then that should give, oh my gosh. Oh, that's very wrong, isn't it? Ah, I see what has to happen. I did this on the wrong piece here. That has to be the framed thing. Okay, so there I am going to say, let's see, I need to put that humph. Let's see, I have to do this. Well, I can do it in a kind of cheating way. I can say that goes to framed #2, comma, background, arrow yellow. Yeah, I think that will work. Yeah, there we go. Okay, so this is having changed every noun to be yellow. And then what I want to do here is take that result and change. Let's see, those are all string joins. So I think what I want to do is take that thing with string join replaced by list. No, what did I do wrong here? Okay, so I've got line 84. Let's take a look. Input form. Wow, that's pretty weird. Let's just take a look at what it really is underneath. Oh, it's string expression, not string join. That's my problem. String expression here. Turn this into just a list of things. Here we go. And now all I have to do is say, take that as a row. And I should be able to get a nice, there we go. So there's a nice version of the Gettysburg Address with all the nouns, all the reversed nouns rendered with the yellow boxes. Okay, so let's. I'm just trying to make nice graphics that we can use to illustrate these problems that we've been doing. So let's remove this here. All right, so people are working on problem 8, which is the text edit distances of the Declaration of Human Rights relative to English. Oh, terrific. We've got 3 correct solutions already for this. Okay, so did you send them through?
In summary.
Okay. All right. And the first correct solution came from the Fox Goat. And that solution, let's take a look here. That was problem 8. So, okay, the Fox Goat solution here is wake up computer. Wake up computer. There we go. Okay, this is here we go. Okay. Oops, languages. I have to evaluate languages over here. Really, there's a version of the UN Declaration of Human Rights in Latin. Funky. Okay. All right. Now it's probably having to load in those actual pieces of text into my computer. And meanwhile, second place is the Cheminator. And the solution given there is, let's take a look here. Actually looks quite similar, quite similar to the Fox Goat solution. Let's see. And interestingly, well, so it is interesting what the result is here. Wow. Esperanto is closest to English. I'm really surprised, actually. I thought Esperanto was much, was actually, well, it's kind of good sign for Esperanto that it's that close to English. Okay. Oh, wow. Is this really right? This was the Cheminator solution is character for character the same, isn't it? Yeah. Cool. Okay. So third place is Total Annihilation, and Total Annihilation solution looks a little bit more complicated. Not much. There it is. Wow, that's a. Oh, I see. That's actually looking for. Wow. Okay, that's being more careful, I guess, or more detailed in searching for the relevant text passages. But what you see here is literally just asking to sort the languages by the edit distance of the English human rights from the human rights for that language, which is specified as UN human right as the string UN human rights followed by the name of the language. Okay, so it's an interesting sequence here. That we don't have Dutch here. Dutch is often very close to English. So Esperanto, French, Danish, Spanish. Okay, interesting. And Maori. This is a little odd. I mean, what we're seeing here is that things like Chinese are. Is this thing given as a transliteration? Because it seems very odd that Chinese would actually. Let's take a look at what at the UN human rights for China looks like, because I think that I don't quite understand. It isn't just no. I don't understand that. So that's definitively not ordinary characters. Yet I'm sure if we look at, I even think is in characters. So I'm confused, but I guess that can happen because the edit distance. Well, what is the edit distance from a Chinese character? Let's just take a look at. If I do this and I take a couple of characters there and I ask what's the edit distance from those characters in Chinese, to ABC, I'm really very confused by what this will be, because I would think, oh, I see what's happening. No, that's really odd. Those have spaces between them? Yes. There will just be 3 because every character is different. So I see. So what's really happening is when those things have a shorter edit distance, it's because the spaces actually lined up with the English language version. And because this Chinese version had spaces every other character, it has a better chance to line up with English than Maori, which doesn't have spaces every character, but I guess its words are so misaligned with English that that it ends up being. All right. Well, let's see what the solution from the okay. The winners there were Foxgoat in first place, Caminator in second place, and Total Annihilation in third place. Good stuff.
The main prizes should be coming over to the other room as we speak.
Okay, so
overall, I think we're wrapping up at that question.
Okay, all right, fine. So question 8 will be the last question for the night. So look, we're going to figure out who the winners are. Well, why doesn't he send it over? All right, so it's very interesting, just to comment for people both on the live stream and here. I mean, you know, every time so this is about the 3rd time we've tried to do a live coding competition event, and each time it's gotten a lot better. This is really getting fairly clean, but we've still got a bunch of issues, and it's oh, what's this? Okay, here are some prizes arriving. Okay. And okay, so we're still trying to work out. I'm going to say that we've been live coding competitions, I hope, are going to get more and more exciting and dynamic. This one was a data point in that process, and this one, we're I think we're steadily debugging the issues. I mean, we've all of the communication of code back and forth has been somewhat complicated. I think, and also the continuing issue is, golly, the problems are being stated in English, and that isn't, you know. But I don't really know how we avoid that. That's kind of the nature.
In code, they're just going to hit Shift Enter. It's done.
Yeah, right. Well, the problems there are different kinds of problems. Like, given this piece of code, find a shorter version of that code. Then it's a code-to-code type problem. But I think this is more interesting to go from natural language to code. But I guess we have to debug even more carefully that there are no possible misinterpretations of the natural language.
Okay. We have the results, but we have an internet connection problem on this computer, but we can give you the computer.
Okay. So the problem is the computer is the computer that has the solutions. Wow. Okay. How can there be somebody with 0 points who's listed here?
Because we realized we marked one of the answers.
Okay. All right. So I'm going to read off. So there's a whole distribution of results here. With so the scheme is 3 points if you came in answered first, 2 points if you answered second, and 1 point if you answered third. And so I'm actually, for people on the live stream, I'm holding a computer here because that seems to be the best way to communicate information. Okay, So now we have all these handles here, so we don't know who anybody is, and we can. But I guess we have to reveal who people are because we have these 3 very, very fine prizes here. Should we announce what the prizes are before we?
For the stream, yes.
For the stream, absolutely.
Yeah, but should we announce them?
The room
Should we
knows.
describe them now?
The room has
Oh, we say the stream
Yes.
hasn't heard it.
Yeah, okay. So there are 3 prizes here. The first prize is something that was created for our 30th anniversary of Mathematica that happened about a week ago, and it is a very distinguished action figure. It's a Lego miniature. Let's see, by what? It's about 1.5 inches. So it's a 50 times reduced model of a tech CEO, complete with graying, I think unreasonably grayed hair, and a laptop, and yeah, actually, I'm looking at myself right now, and this the action fiction has a blue shirt and gray pants, and just so happens that that's what I'm wearing today.
No coincidence.
And I also think this action figure is a little bit more. It's a bit more jaundiced than it's a bit yellower than the real version. Oh yeah, the back, the back is a description. It's a Lego piece. So, a new kind of CEO inventing the computational future since 1988. Okay, well, anyway, when the need for computational intelligence arises, look no further than this text. Yeah, what a fine concept. Yes, right. Well, there's various sentences, and it then says, because this is a description, because usually these are Lego pieces that are of, I don't know what they're of. They're things like dragons and stuff like that, and
Famous people.
they got people too. Okay, I would normally think it was like this is a fire-breathing dragon that has, where features include, rotating tail and stuff like this.
That's the version that I have back at the office of you.
You'll generally find him conquering bugs, writing code, eating chocolate, and even consulting on sci-fi movies. Awesome features. A new kind of CEO comes with a practical button-down shirt, a laptop for live coding, okay, and a wise but kind expression behind glasses. Oh, nice. Okay, so this is the first place prize. The second place prize is a Raspberry Pi. Yeah, that's a Raspberry Pi. Right. And the third place prize, yeah, which comes with Wolfram language. And the third place prize is in the same kind of theme. It's a raspberry in a nice little special food container, ready to eat. Okay. Well, what do we do here? Very conveniently, Danielle, there is a problem here. We've got a tie in third place. So the good no. Let's get a knife. Let's get a knife.
Get a knife and we will after I stop laughing.
Okay. Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. Okay, so we've got 11 people who've placed in the competition. So 11 people, 11 different people had at least one solution within that came in the first 3. So we have a tie for fifth place between Meng Yi and Zhu.
Stand up.
Yeah, applause. What is it? Oh, okay. Yes. Okay, good. Okay, we have a 4-way tie between fourth place, a 4-way tie for fourth place, and all those people got placed twice in the top 3. And those people are Carl. Well, we should hold the applause. We get all 4 people together. Carl, right? Carl, and then FFF, 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 FFF.
Screen name, whoever you are, stand up.
And also Lanston Chu and Keminator. Very good. Okay, in 3rd place, sharing the 3rd place raspberry, complete with, I don't know if this is really a sanitary operation. I mean,
It's been touched by 4 people already. Don't eat the raspberry.
we should give consolation. Oh dear. This really won't work well. Wait a minute. This raspberry had a paperclip inside it.
We were trying to make it stand up and look important.
This is okay. We've got some consolation raspberries, I believe. We have some extra fruit, I think. We should provide consolation raspberries. Okay, so and raspberry halves go to Maxit G and Terminate. Okay, very good. I don't know whether we can really. I'm not sure this is worth presenting. I don't know what. Yeah, we got to have a. Yeah, we should. Yes, right. No, you don't want to eat it. Don't want to eat it. Don't eat it. Don't eat it. It's these.
Save the seeds and grow raspberries next spring.
Maybe wait, can both of you hold it?
Yes, you both hold it.
Yeah, let's.
This is a very prestigious moment.
So I should say, by the way, that both these folk got 5 points in our scoring system, and okay.
It's like a wishbone.
Oh, well done. Oh, great. Okay, so in 2nd place with 7 points, the winner of the more useful raspberry pie is Total Annihilation. Aha. Ta-da. Do you already have one of these or not? Oh, sure. Oh, no. Okay.
Oh, you can set up another server.
Yes, he set up with Mathematica on a Raspberry Pi earlier today that was running.
Oh, okay. So, all right. And the 1st place with, so Total Annihilation got 7 points. And the 1st place with 15 points goes to the Fox Goat. Oh, no. Oh, well, you know, I kind of had a suspicion about the identity of the Fox Goat. There's the Fox Goat. The Fox Goat is happens to be genetically.
How many kids can say they have an action figure of their dad?
So the Fox Goat turns out to be none other than Christopher Wolfram, and Fox Goat. You kind of get the fox. I didn't get the Fox Goat. As
The one who learned how to speak Wolfram language before English.
It's very true.
Well, okay. It's all right. Well, I think that's probably it for our live
They still have a
code.
deadline by midnight tonight to get
Oh,
homework in.
oh, yeah. Well, so just for people on the live stream and for people here, we have this great homework exercise of writing a computational essay about something, and everybody here, we should extend this deadline. This is too late.
We could probably extend it.
I just want to make sure to read all these computational essays. So,
Alright, so okay.
Oh, now we get.
okay. Kyle is a professional educator, so he knows about stuff like this. Okay, great. Thanks for participating, everybody. Thanks for folks on the live stream.